Thank you for joining us on HXGN TV. I'm your host, Bill Fetter, and today we have another edition of Fast Talk about metrology. Today's guest is a former world land speed record holder and current director of the BLOODHOUND SSC project, Sir Richard Noble, OBE.
Thank you. Thank you.
Richard, thanks for joining us.
This is absolutely my pleasure. Yeah.
First, could you give us a brief introduction to the BLOODHOUND project?
Yeah. What happened is that the World Land Speed Record tends to be a bit of a very friendly battle between the British and the Americans, all right? And you guys completely dominated it during the 60s and the 70s.
Right, but not so now.
Not quite so now, so waiting for a comeback, you know. And, well, what happened was way back in 1997, we broke the sound barrier on land for the first time. And this was a huge, huge thing, and our website was the 5th largest in the world. It was a massive thing. And then a great American, the late and great Steve Fawcett, decided he was after us. He was going to take the record away. So we decided what we'd try and do is to kind of outpace him by setting the standards so high that we could probably outdo whatever he might do. Unfortunately, as you know, Steve was killed in a flying accident, which is just rotten luck. It really was. Anyhow, so we set about building a car now that would do Mach 1.4. That's 1,000 miles an hour. And it's been an enormous program. It's taken 200 man-years to get the car designed and built. But we've got it built now, and we've got to get it running next year. Yeah. And next year we'll get up to 800 miles an hour.
Ah, fantastic. And this is a model.
This is a 120. It's quite a big car.
Yeah.
It's just on 14 meters long.
Okay.
It weighs 7.5 tons, and it's got 135,000 horsepower.
And that horsepower is derived from sort of a hybrid engine of sorts.
There are all sorts of engines in this thing,
Yeah.
actually. What we've got is a Eurofighter jet engine, which is the most advanced military engine in Europe. Then we have a hybrid rocket motor. The rocket motor produces around about 60% of the power, the jet engine about 40%. And then in the middle of the car, we have a V8 Jaguar engine, 5.5 liters.
Right, and that's the fuel pump, right?
That's the fuel pump.
Right.
Now you took it from me. That's the fuel pump for the rocket motor, yeah.
That's fantastic. So you were also involved with Thrust SSC,
Yep.
right? The current record holder from 1997.
Correct, yes.
And
Yep.
Andy Green was the driver of that
Yeah,
car. And
he did really well.
He is the planned driver for this car.
Absolutely, yes. It's designed around him.
All
Yeah.
right, so 763 miles per hour Thrust SSC to 1,000 miles per
Yep.
hour. That's a lot of difference in the speed, but we've got 20 years of engineering technology in between then and now. So how have things changed?
Well, things have changed enormously because basically, as you rightly say, the technology has increased, and of course we use Hexagon products very extensively. But of course, the fundamental thing is that nobody really knows how a vehicle like this is going to perform at these speeds. Right. Now, we've done an enormous amount of computational fluid dynamics, vast amount of work on this, and we've actually innovated all sorts of new initiatives there, and we can actually control the shock waves now underneath the car, which we certainly couldn't do before. So that's a huge advantage, and we think that the design is benign. It's going to be safe. It isn't going to dig itself into the ground, or it isn't going to fly.
Right.
But there's an awful lot of learning to do.
Yeah.
Another thing which is really interesting, which is that the speed of sound through the Earth, of course, remember the car's running across the desert, through the Earth is faster than the speed of sound through the air.
Yeah.
So there's a danger that the shock waves going through the desert will break up the desert before the car gets there. Okay, so there's an awful lot of metrology to go on here.
Right, and I know you've even done metrology on the floor of the desert.
That's right, absolutely. That's all been lasered, yeah.
Yeah. So how does Hexagon Manufacturing Intelligence come into the story here?
Well, it comes absolutely crucial. The thing about these very, very high performance vehicles is that they've got to be absolutely accurate, just totally accurate. Yeah. And Hexagon joined us right at the early stage of the project, and we've used the CMM and we've used the ROMAs extensively. And we're extremely grateful because it's enabled us to get a really top record car.
So what value do you think that you've gained from this? Are you confident in the results that you've obtained? I mean, we've got a whole lot of factors here, obviously.
That's right, Bill. Yes, we're very confident in terms of what we've learned from our research and how we've applied that research. So we're really confident about that. But of course, we're moving right into the unknown here. Yeah. Nobody's ever done anything like this before, so we're going to learn an awful lot.
Yeah, and I imagine that there's part of this is quality control on the parts themselves, but it's also the assembly of the actual finished vehicle.
Absolutely right. Absolutely right. You know, this is we've got to run this thing to a very, very close tolerance.
Right. Yes.
And of course, the other thing too is it's about the data. We've got to be able to get vast amounts of data off this car and use that data to predict the performance. So we're always just sort of one jump ahead.
Right. Well, it's a 1,000-mile-an-hour prototype, isn't it?
That's exactly. There's only one.
Right. one for the record. So obviously, a 1,000-mile-an-hour car is a fantastic achievement, but that's not your only goal here, is it? There's something else about this project that's really important to you.
Bill, you're leading me on here, but you're absolutely right. We've had an extraordinary experience. Basically, of course, as a team, we set out to build this car. We didn't quite know how to market it. You know, it's a bit of an extreme thing to sort of go ahead and do. And we had an extraordinary experience. One of the ministers in the government told us that they got a huge problem in the Ministry of Defence, the equivalent of your Department of Defence. They can't recruit scientists and engineers because there just aren't any. And what's happened is somehow the media has taken some sort of control, and basically the kids just don't appear to be interested in science and engineering. And we were told, would we please run this car through all the schools in the country and see if we can change things.
Okay. And what's been the result?
The result is fantastic, but I'd just like to just look back at it slightly, because we learned so much from the NASA program. Because during the NASA program, this is putting Neil Armstrong on the moon. Right. During that program, the increase in the number of graduate PhDs in engineering, in science, and in mathematics is absolutely enormous, about a 300% growth. What you guys did, it was very clever, you turned on the entire country. The weakness was, of course, it was dependent on television. And of course, the internet wasn't around way back in the 1960s. We've got the internet today, and we can make this available. So at the moment, we've got all the kids building rocket cars at the moment. The fastest kid's rocket car is 530 miles an hour.
That's pretty good.
And we've got 40,000 kids doing this at the moment now. Wow, so it's getting really very big indeed. And it's really working. It's turning them on. They're all getting excited. It's competitive, and it's really good. We're really learning something from this, and we're getting change.
Fantastic. So what do you think is going to be the lasting impact of this project?
Well, let's hope we're successful. That's the first thing. You know, there's an awful long way to go now, but let's hope we're successful. If we're successful, then what we're doing is we're taking all the data off the car live at up to 1,000 miles an hour and putting it on the internet. So all over the world, the kids can start studying this and predicting how we're getting on. And basically sort of, second guessing what our engineering team is doing.
Right.
It's going to be fantastic. We're in 220 countries at the moment now, so it's getting really big.
Marvelous, marvelous. So how representative do you think that the technologies that you're deploying in the project today are to what young scientists and engineers who are coming out of college and getting their first jobs? How representative do you think that what you're doing here is of what they would experience in the job market?
Bit of both, really. I mean, the key thing that we're doing is creating the inspiration. We've got a big problem in Britain in that basically our kids are not being given enough education. No, sorry, enough inspiration. So they need something like this to really learn from and say, hey, you know, I want to be an engineer. That inspiration leads to the aspiration, and then they take their education a lot more seriously. And of course, basically what we're doing here is we're using vast amounts of data to create this vehicle. And as I say, you know, it's taken 200 man-years to get to this point. And all that is being made available so they can copy it.
So has there been anything that's really surprising to you that's come out of this this experience with the kids?
Yes,
what have you learned from the kids?
Well, let me tell you a story. There's a guy who runs a bloodhound club.
Okay.
So we have quite a few of these, and these are clubs which are attached to schools, after-hours education. And one day he rang up and he said, I'd like to bring the kids down. They're aged 11, 12, 13, 14. I'd like to bring them down and to meet you and Andy Green. So could we do this? And I said, yes, of course, absolutely. So there we were. We found ourselves in our conference room with, I suppose, about 15 kids. And they started asking questions that we could not answer.
Really?
Yeah, this was amazing. We weren't ready for this at all. And we realized what was actually happening was these kids are studying this in enormous depth. And of course, we're running the project and doing the project. We can't go into it at that sort of level. Fascinating. I mean, we're going to see big change. It's really amazing.
Exciting, very exciting. So what's the status of the car now? How are we doing?
Okay, well, we've been doing quite well in terms of getting it built, because there are a number of different phases in this, and also there's different psychology involved in the phasing, which is really interesting. So the first bit of it is basically building the car, the design, research, and build of the car, which is what we've done. We're 95% complete. We showed it in London, and 8,000 people came in 2 days to have a look at it. So that was really good. So we thought, great, now we're all set now for the next phase, to raise the money for the next phase. And Bill, it didn't happen. It was a nightmare. There we got everybody really excited, and then it all seemed to go flat. So we've had with the better part of 8 months fighting to survive, and then suddenly, literally about 2 weeks ago, we got 2 enormous deals. So we're okay.
Okay. On to the next phase.
So on to the next phase now, which is at the end of this month, we take the car to pieces. Okay. We've then got about 8 months' work to put it all together again and make sure everything's ready, everything's connected up and ready to go and everything else. Then we run it in England on the runway down in Cornwall, where we just check it out, make sure everything works all right.
How fast there?
200 miles an hour, nothing serious.
Just to make sure it works.
Yeah, that's right, yes. Make sure the rocket works and the whole thing works. And then basically we bring in the airplane, load it up and take it down to South Africa.
You're loading it up full built into the airplane? Or do you have to take it apart to get
No, we're not going to take it apart. We take the fin off, of course, but otherwise just put it straight in.
Yep.
And then fly it straight down to a town called Appington in South Africa. And there we have the Hexagon desert where we're running. And we've spent, or rather the Northern Cape government in South Africa has spent 600 man-years getting this desert ready.
Really?
They've employed 300 people for 4 years. They've lifted, by hand, 15,800 tons of stones. It's absolutely amazing. And we've seen change, tremendous change, because the local people largely are unemployed. They're desert people, they don't have the skills. And the extraordinary thing about this is, as a result of Bloodhound, they've now got Bloodhound education. Basically, as a result of the MTN people who built the transmission towers, so now we can take the data and take it across 200 kilometers of desert. They've now got better 4G than we have in London. And basically the local government has now put in a 143-kilometer pipeline. So it's fantastic. These people have now, their whole lives have changed as a result of this.
Right. The project has improved the lives of the locals there
in a very big way. Yeah, it's got very powerful social consequences.
I bet you didn't anticipate that when you started.
We certainly didn't. We really didn't. But I mean, it's just wonderful the way this is happening.
Yeah.
And of course, it's going to be open, so people can just simply get on a plane, come down to South Africa. It's all nice and safe. There's no problems there. And come out, drive out to the desert, and come and see this thing run.
So, how much desert do you need to get to 1,000 miles an hour?
We've got 12 miles or 20 kilometers.
Miles. 12 miles.
We do it.
How much margin is there in 12 miles?
Not a lot.
Not a lot. And you got to stop too, right?
We've got to stop, yes. Right. Otherwise, Andy Green will find himself in Namibia, which is not such a good thing.
Right. Very good. Very good. So when are you anticipating you're going to get the car down there?
I think we're going to be down there around sort of September, October next year. That's what I think.
All right.
And it's a very complex vehicle.
How long do you have to be in the desert before you can to prep and everything?
Well, basically the way we'll set it up is that we'll be all set up so when the car arrives, we'll be ready to go. We'll be ready to go within 2 or 3 days of arrival. And then gradually we just increase the speeds all the time, taking the data all the time, checking that data against all the research, keeping going, getting faster and faster and faster.
Letting the kids keep an eye on the data for you.
Yes, absolutely. Yeah. And of course they'll be responding. Now this is one of our big problems. How the hell do we deal with 20 million kids who ask us questions? Right. So we've got to settle that one.
Maybe we'll be talking about that one next year. We'll have some ideas on that. All right, we're just about out of time. We'd like to thank our guest, Richard Noble. To learn more about the Bloodhound Project, check out bloodhoundssc.com. And for more information on Hexagon metrology and manufacturing intelligence products, would you please visit hexagonmi.com. And for more on Hexagon TV and additional episodes, please visit hxgntv.com. Thank you for watching.